Hello students, we are solving the IB Math AHL past papers and currently we are solving the IB Math AHL November 2021 paper 1. And today we will be solving the question number 7 of this paper. You will be getting the links to all the previously solved questions of this paper and of the other papers in the description area in form of playlist. So without any further delay, let us start answering question number 7. The maximum mark is 7. The equation 3px squared plus 2px plus 1 equal to p has two real distinct roots. It is a quadratic equation and it is having two real distinct roots. Subpart A says find the possible values for P and it is containing 5 marks. Okay. So, first thing that we will be doing is, what do we do? For our quadratic equations, we always have all the terms on one side of the equal to sign, that is the left hand side, and we put the right hand side, we have the right hand side term as 0. That is our usual conventional quadratic equation. When we attempt to solve a quadratic equation, we always bring all the terms, the non-zero terms, to the left hand side and we keep the right hand side equal to 0. Okay, so that is the same thing that we will be doing for this quadratic equation, and I am starting my answer from this point. I'll be bringing p to the left hand side, or I will be adding negative to p to both the sides. Okay, so 3p x squared plus 2px plus 1 minus p is equal to 0. Okay, now since this equation has two real distinct roots, therefore the discriminant should be greater than 0. And discriminant, what is the discriminant expression? It is b squared minus 4ac. This should be greater than 0. Okay. And what is b? b is 2p. So therefore, 2p whole square is 4p squared. Or let me write this first of all. 2p whole square minus 4 times what is a? 3p. And what is c? 1 minus p. This should be greater than 0. So this is 4p squared. And this one is 12p times 1 is 12p minus 12p. And this is 12p times p. It is plus 12p square. Minus and minus will be giving us a plus sign. So it is 12p square is greater than 0, or I can write this as 16p square minus 12p is greater than 0, or I can take out 4p. So 4p and 4p minus 3 is greater than 0. Clear? Okay. Now this is an inequality. How do we solve? We can straight away draw a parabola and we can find the values for p, because that has been asked for in subpart A. So we will be sketching a parabola. But there is slight problem because we do not know whether p is a positive number or a negative number. So if we want to sketch a parabola, if p is a positive number, then this term 3px square will be a positive term and the parabola will be opening upwards. And if p is a negative number, the parabola will be opening downwards. Clear? So we can, even then we can try to sketch the parabola. We will be taking both the cases, opening upwards and opening downwards, or else what we are having over here, 4 cannot be greater less than 0. 4 is not equal to 0, 4 is not less than 0. The product of 4 and p and 4p minus 3 should be greater than 0. That is what we are given in this inequality. So 4 is a positive number, definitely. But we do not know whether this p or this 4p minus 3, whether they are positive or negative numbers. So we have two options. Either p is a positive number or p is a negative number. Let us start with the negative number. Okay. If p is a negative number, this one will be a negative number. And 4p will also be a negative number, minus 3. So this will also be a negative number. So this negative number multiplied with this negative number will be giving us a positive product. When multiplied with 4, will be giving us a positive number. Clear? We can take any value of p, any negative value of p. We may take p as negative 2. If p is negative 2, and this will be 4p will be negative 8, negative 8, negative 3 added together will be giving us negative 11. Negative 11 multiplied with negative 2 will be giving us positive 22. And that multiplied with 4 will be giving us a positive 88 as the product. So when p is any negative number, we are seeing we are getting a positive product. Okay. So when p is less than 0, p times 4p minus 3 is greater than 0 for every negative value of p. So we can take p as a negative number. Okay. The parabola will be opening downwards. Finished. So p is less than 0. This is one set of values for p. Can p be any positive number? What happens if we consider p as a positive number? If p is a positive number, this 4p will be positive because 4 is a positive number, p is a positive number, the product will be a positive number. What about this part, 4p minus 3? 4p minus 3, if p is say 1, so 4p minus 3 will be 4 times 1 is 4, 4 minus 3 is 1. It is a positive number and 4 times 1 will be 4, times 1 will be 4, a positive number. Fine. The product is positive. But if we take p as 2, even then we will be getting a positive product. But what if p is equal to half? Half is also a positive number. If p is equal to half, 4p is positive. 4 times half will be 2. It is a positive number. But what do we get for the 4p minus 3? What value do we get? 4 times half is 2 and 2 minus 3 is negative 1 and 4p is equal to 2. So 2 times negative 1 will be negative 2, which is not greater than 0. So p cannot have a value of half. P cannot have any fractional value between 0 and can p have every positive integer value? Definitely. But do we have to reject every positive fractional value of p? Let us see. Because if we have any positive fractional value for p, the 4p part will be a positive number. So we have to get the condition for 4p minus 3. That should be a positive number. Okay. So when p is greater than 0, 4p is greater than 0. Okay. What about 4p minus 3? Therefore, 4p minus 3 should also be greater than 0. Okay. Therefore, 4p minus 3 is greater than 0 gives us the p values as p is greater than 3 over 4. So we can take fractional values of p. Okay. 3 over 4 is 0.75. So p can have a value of 0.8. That can be taken. Okay. But we cannot have p value as 0.5, which is half. We have seen. Okay. Therefore, we are having two possible range of values for p. One is p is less than 0, and the other is p is greater than p of 3 over 4. Okay. So this is p is less than 0 or p is greater than 3 over 4. So we did not have to reject every fractional value. Okay. And we have got 5 marks. Okay. Coming to subpart B. Consider the case when p is equal to 4. P is a positive number and p is of course 4 is of course greater than 3 over 4. The roots of the equation can be expressed in this form where a is an integer. Find the value of a. It is containing just 2 marks, has to be because we will be substituting 4 in place of p. So this is 3 times 4x square plus 2 times 4x plus 1 minus 4. I'm taking this one is equal to 0. So this is actually 3 times 4x square, so 12x square. This is 8x minus 3 equal to 0. Okay. And there is this radical sign, so we have to use the quadratic formula. Fine. So we can write therefore x will be minus b plus minus under root. So minus b, what is b? 8. So minus b, it is minus 8. Plus minus, I'm not writing the formula, I hope you know. Okay. Or else I may write it over here with another color. So this is x equal to negative b plus minus under root b square minus 4ac over 2a. Okay. So this is the formula, quadratic formula. So plus minus b square under root b square is 8 square is 64 and minus 4 times what is a is 12 and c is negative 3 over 2a, so 2 times 12. So this is negative 8 plus minus under root 64, and this is what? This is 4 times 3 is 12 and this is 12. So 144 and this negative sign multiplied will be giving us a positive product. So it is plus 144. Okay. So this over 24 and okay. So 64 plus 64. If you want, I can do it. 60 plus 140 is 200 and 4 plus 4 will be 208. So I'm not doing the addition. If you want, you may do it. Because it is paper 1, you cannot use the calculator. It will be minus 8 plus minus 208 over 24. And now we have to get the factors of 208. We are seeing that in the denominator we are having 6. So, and over here the coefficient is 1. So, outside you are having 1. So, it is quite obvious that the numerator and the denominator, they are getting divided by 4 because 4 times 6 will be giving us 24. Let us get the factors of 208. Okay. So, let us do it over here. 208, 104, 52, 26, 13. Okay. So it is, this is 2. These two taken together will be giving us 1, 2. 1, 2 will be coming outside the radical sign, and from these two, this pair, another 2 will be coming outside. So 2 times 2 will be 4. So this is negative 8 plus minus 4 root 13 over 24, which is, now we are dividing both the numerator and the denominator by 4 to get negative 2 plus minus root 13 over 6. Okay. So, a plus minus root 13 over 6. Therefore, a is equal to negative 2. A is equal to negative 2. So we have completed solving question number 7. And I'm Nilanjana Sanyal. I tutor IB Math A, HL and IB Math A SL level students, both from within India and outside India. And I am starting my group online tutoring sessions. They will be small groups for IB Math A SL students and IB Math A HL students. In case you are interested in joining my group sessions, you may contact me for more details. You are getting my WhatsApp number being displayed. You are seeing my WhatsApp number getting displayed. You are seeing my email ID getting displayed. So you may contact me for more details. Okay. And thank you for staying with me till the end. We meet again in our next session where we will be solving question number 8 of this same paper. Till then, bye.